Okay, so we left off talking about rigid and non-rigid transformations. Now, out of the four main transformations, I've got translations, I've got rotations, I've got reflections, and I've got dilations. Okay, out of those four main groups, you can probably already figure out which one is the non-rigid transformation, just using these two indicators. Do the angles stay congruent? Do the side lengths change? Which of those four main transformations do those things? Okay, so again, just make sure that you know rigid and non-rigid, and then I'm going to just give us definitions of each of these four, and then we'll be done. I'm going to start a new page. All right, so we'll start with translation. This is the one that you've probably used the most often when you're doing things. And a translation is a transformation that moves every point of a preimage the same distance and direction. So if I drew a triangle, I'm going to call it A, B, C. A translation doesn't change the triangle's orientation. It doesn't flip it. It doesn't do anything like that. It just says, hey, I'm going to move C this far this way. Which means, guess what? I need to move A exactly the same distance that way, and B exactly the same distance that way. So then now I have my image, C prime, A prime, and B prime. Now that wasn't perfect because, of course, I'm not on a grid and I didn't do a perfect job of it. But the idea is the same. Each of these lines that are my translation are supposed to be exactly congruent to each other. So a translation is a rigid transformation because not only do my angles stay the same, but my side lengths stay the same. I'm not moving one a certain distance and then changing the distance between two different legs. Again, I'm sorry that my drawing is not to scale. Okay. All right. The next one is a reflection. All right. A reflection is a transformation that uses a line, like a mirror, to reflect a figure. Now, this one is kind of hard to see if you have a dot, just a single point. But if you have a shape, like let's say we have a shape like that, okay, and this is A, B, and C, okay, what you would have is you would have a line of reflection. Let's say the line of reflection is here. And you would reflect each of those points over that line of reflection. So you would have to pretend like there was a mirror here and see where that B would end up on the other side. And the B is going to end up somewhere like right about here, B prime. The A is going to end up somewhere like right about here, A prime. And the C will end up somewhere like right about here, C prime. Now again, I know that this is not to scale in TS, but I did my best for it, okay? Now again, you'll notice that the side lengths are supposed to stay the same and the angle measures are supposed to stay the same. So this is also a rigid transformation. Okay, so reflections are rigid transformations. Okay, and then a rotation is a transformation that turns a figure about a fixed point. So when I think about rotations, I think about like ballerinas and stuff and how they turn themselves around, but they still are the same ballerina. So if I were to draw triangle, let's call it A, B, C. If I were to rotate it, let's say I rotate it around C, and then I might have A, B, C, A prime, B prime, and C prime, okay? So the shape, again, remains the same, but I've rotated it. I've changed its location. So this is another rigid transformation. And again, I'm really sorry that that was not to scale. Okay. All right. And then the last, but certainly not least one, is a dilation. And this is a transformation that enlarges or reduces a figure. So when I'm looking at a figure like this circle, my dilation could make it bigger or it could make it smaller, okay? And because the side lengths are not always the same, this is not rigid. Not rigid. This is the only non-rigid transformation.